Okay, class. So we started with the harmonic waves. We have to complete the equation of harmonic waves and many things. So let us just complete this. So particles of harmonic wave are in SHM. So when you write the equation of the particles, see, before coming to the velocity of each, this is the standardized equation. Y is equal to a sine kx plus minus omega t plus phi naught. What are all these things you need to understand? Okay, when we say y is what? Y is the displacement of the wave. This is the displacement of the wave. What is a? A is the amplitude. Sine, and instead of theta we have this. So we have discussed this before also. What is k, what is x? Basically you need to remember this for plus minus. How to find out plus minus? See, this value will determine your axis, whether it's x axis, y axis, whichever axis it's. Phi naught, you know, it's the phase difference. But when we talk about this plus minus, how to identify whether it will be used plus or minus is, if the wave is along the positive direction, you put a minus sign. Okay, and when the wave crosses along the negative, then you put a positive. For x-axis, I have written, for all the waves, it will be the same. Write it down so that this is the equation of displacement. Now we'll come to the equation of particle velocity and acceleration. Please write this. Harmonic waves mean simple harmonic waves. SHM. SHM waves. Done? See, when we're talking about the particle velocity, wave velocity is the velocity with which the entire wave is moving. But when we're talking about a single particle, is from that wave which is moving, that is known as the particle's velocity. So what we do, we take the particle's equation, that is the equation of displacement a sine omega t minus kx plus phi naught. Okay, now particle velocity will be dy over dt. So when you differentiate it, this will be a sine omega t minus kx plus phi naught. Okay, so this will be equal to a minus omega cos. What all will be left? Kx minus omega t plus phi naught. This term and rest of the things will be multiplied. So what can we say? We can say the maximum particles velocity is minus omega a cos kx minus omega t plus phi naught. Now see, if there is no phase difference, that is the maximum value which is possible. Okay, if I say velocity, maximum velocity. So maximum velocity, when can we have maximum? What can be the maximum value of cos theta? It will be 1, means your theta is 0. So technically class, when we write no cos theta, everything within the bracket is your angle. It means this angle will be 0. So maximum will be V will be V max cos omega t minus kx. This will be the maximum velocity. See, remember omega a. All of you, do you remember the maximum particles velocity? In terms of position, we did this. This was minus omega a cos omega t minus kx. So V max is omega a 2 pi a by t. Write it, then we'll see particles acceleration. More than these derivations, na class, just focus on the final formula. Final equation will be very useful. Please write this particles velocity first. Okay, coming to particles acceleration. So see, how do we calculate acceleration? Particles acceleration will be given by differentiation of velocity. So you differentiate velocity over time. So this d over dt, this is minus omega a cos kx minus omega t plus phi naught. Right? So simple when you remember the final conclusions only, class. These derivations are not very important for you. So this is minus omega a omega sine kx minus omega t plus phi naught. So finally the particle's acceleration will be omega square a sine kx minus omega t plus phi naught. Okay. So this is the equation of acceleration. Acceleration, and this is velocity. Now there's a question, class. Y is equal to 0.05 sine pi by 2 10x minus 40t minus pi by 4. Class, all these questions are very easy. If you get such questions in class 11, this is very easy. You just have to have the main equation ready with you. See, if we say y is equal to a sine omega t plus kx, so just compare it with the equation. Your main equation should be ready. This is the equation of displacement. We have to calculate particles velocity and acceleration. Now here we don't have to find out omega or something that we need to compare. We can say you have displacement, differentiate it, you will get particles velocity. Differentiate your answer, you will get particles acceleration. That's it, what you have to apply. It's just that you have to substitute the time also. So when you have particles velocity, this is dy over dt, which is d over dt. This is 0.05 sine 5 pi x minus 20 pi t. See, I've multiplied this pi by 2 within this. So that's why I'm writing 20 pi t here. Okay, minus pi by 4. All right. So when we are writing the particles velocity, this will be, I think the answer will come around 2.2 meter per second. This you can check. And yeah, class, the answer is this only, because acceleration, when you differentiate a constant value, what should be the acceleration now, class? If this is the velocity, tell me. This is the velocity. What should be the acceleration? Yeah, class, answer. Yes, Jobita, Shaima, Ali. Particles velocity is this. Differentiate 2.22. What will you get? Yes, Ali. It's a constant term. When you will differentiate it, you will get 0. That's it. Class, just remember one thing. When we are talking about the particles velocity, it is omega a. When we are talking about the wave velocity, it is omega by k. Be very clear with these two differentiating values. Okay, further we can write omega as 2 pi by t, and this or it as 2 pi mu. Is it clear to all of you now? Is it clear? Okay, see class. So this was the difference between the particle velocity and wave velocity. So when you have the equations for the particle velocity, you will differentiate the equations, right? That's what we have already studied. This I've told you. Now, intensity of wave, this is not very important, but it can be asked. Intensity is equal to 2 pi square of frequency density into the speed of wave into the square of the amplitude. It's a very big formula, but no derivation, nothing. Just look at the formula once before attempting the exam. This is not very important. I'm again saying this. So this is the density. This is the speed of wave. This is the amplitude. All right, now there's one very good question. The equation of traveling wave is this. You have to find out the ratio between the maximum particle velocity and maximum wave velocity. See class, when we are talking about maximum particle velocity, it is omega A. When we are talking about the maximum wave velocity, it is omega by k, as I told you. So when you write Vp by Vw, this is omega A by omega. K will go up. Omega gets cancelled. This is A into K. What is amplitude? Amplitude is 10. What is K? Kx. So this will be 3. So ratio is 30 by 1. 30 is to 1. Is it clear? Are you people hearing? Is it clear to all of you? Jesleen, Shaima, Jobita, Ali?
Yes, ma'am.
All right then. Just write down this part. Then we'll do something else. Okay, coming to the concept of stationary waves. So stationary waves concept is very easy. You just have to know if two waves are there, they are having the same amplitude, same frequency, same wavelength, but they are moving in the opposite direction. They superimpose to give a new wave. That is called as the standing wave. That's it, what you need to remember. Two waves are there having the same amplitude, frequency. It's just that they're traveling in the opposite direction. Energy remains confined in the region. It means, suppose this is the rigid end, this is the incident wave. This is the reflected wave. One you can take positive, other you can take it as negative. So y initial will be a sine omega t minus kx. Reflected will be a sine omega t plus kx. In superposition principle, we have studied it multiple times now, that you add initial plus reflected, which will give you the resultant. So y is equal to a sine omega t plus kx plus a sine omega t plus kx. Okay, we are just, okay, no, one will be minus. No, this will be, one will be minus. We have just added the equation. So when your final equation of stationary wave will be 2a cos kx together and sine omega t together using the identity. Again, I'm saying don't focus on all these equations, derivations, just come straight away to the equation. So this is basically equation of resultant wave. This you need to remember. What is the equation of resultant wave? So what will be the amplitude? Class C, I told you everything before sine theta is your amplitude. So here your amplitude is going to be 2a cos kx. Remember, this is not just going to be simply a. It is going to be 2a cos kx. Okay, now what are nodes and antinodes? Basically, if I draw a wave, see class, these points which have not moved at all, these are called as nodes. And these particles which have completed maximum displacement, these are called as antinodes. So sometimes you have to find out the number of nodes and antinodes also. So in case of a node where the amplitude is 0, we will put r equal to 0. So your 2a cos kx will be 0. Cos kx will be 0. Straight away your theta will be 90 degree. So when can you have the values of nodes as 0? Your k should be pi by 2, 90 degree. Then again 3 pi by 2, this is also 0. 5 pi by 2, this is also 0. So a better way to remember, till how much value will you calculate it? So a better way to remember this is 2n minus 1 pi by 2. Okay, this is the equation where your n can be 1, 2, 3, 4, 5, 6, anything. Here the n can be 1, 2, 3, 4, 5, 6, anywhere. Okay, this can be the value of k. So when you're writing k is 2 pi by lambda, the formula of k, if you have forgotten. So if you have to calculate something else, let's equate it. 2 pi by lambda is equal to, what is the value? 2n minus 1 pi by 2. Pi getting cancelled. Equation of x, finally, we are getting this as 2n minus 1 lambda by 2. Okay, because here this is 2 pi x. I have forgotten this x here. Yeah. So 2 pi x will be 2n minus 1 lambda by 4. Sorry, this 2 will also be multiplied. So this will be by 4. So remember this equation. This is the equation which you need to focus on and remember. Okay. So now with this, you can calculate the position of any node. If I want to find out what's the position of the first node, I'll put n as 1. So x1 will be, see, this is 1. 2 minus 1 is 1 lambda by 4. Similarly, if I want to get the position of second node, I'll put this as 2, n is equal to 2. So x will be 2n minus 1 lambda by 4. This has 2. 2 into 2 is 4. 4 minus 1, 3. This will be 3 lambda by 4. Like this, any value, any point of node can be calculated. Because in nodes, you have minimum displacement. Now, in antinodes, you have maximum displacement. Maximum displacement means your 2a cos kx. What is 2a cos kx? This is the 2a cos kx. This is basically the region of the amplitude. So amplitude is maximum. Look here. Look at this. If this is a wave, this particle has covered this maximum distance. This is called an antinode. So this will be maximum. Okay, this value will be maximum. So your cos kx, this will be 1 because that's what the maximum value is. When can we have cos theta as 1? Theta will be 0 degree, right? So what all values of kx we have here? 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, like this, simply n pi. So 2 pi x by lambda is equal to n pi this time. Pi will be cancelled, x will be equal to n lambda by 2. So this is the difference. There's a major difference between both the questions. One is, this is for the nodes, x is equal to, this is for the nodes, 2n minus 1 by 4. This is for the antinodes. This is for the antinodes, okay? Is it clear to all of you? Did you understand the two equations? What is the difference between a node and an antinode? Is it clear? Okay. See, who is this? Mukul Nehru?
Hi, ma'am.
Class C, this equation we'll complete later. This question. First, you write down this theoretical part.
Ma'am, can you scroll up for a second? Done, ma'am.
Just 5 more minutes, Jovita.